Good morning, grade 12 math learners. Today we are looking at differentiation of functions from first principles. Now, this part of your study features almost in every paper 1 examination that have been written. So, it is important that you understand the concepts thoroughly so that if it comes, you are comfortable and you will be able to harvest marks from this subtopic. We have shown you already that f dash of x is equal to the limit of f of x plus h minus f of x all over h as h goes to 0. This formula is very important and it's always provided in the examination page. The last page will always give you formulae, and this is one of the formula that will be appearing in your examination at the end of the year. I want to remind you of what we call perfect squares. You should be able to expand quickly a plus b or this squared. This is not a problem. According to the rules of expanding a perfect square, you take the first term and square it. And the middle term is given by multiplying the two terms in the brackets and then multiply by 2. So it will be a times b, then times 2. That will give us plus 2ab. Very, very important. The sign of the middle term will always be the same as the sign between the two terms that you are expanding. And the first term will always be a positive perfect square, and the last term will also be a positive perfect square, which means it will be plus b squared. Very, very important for you to remember that. Which means if it is a minus b or this squared, you have a squared. Remember, this times this, that's ab times 2, and it takes the sign of this, the sign between the two terms, which means it's minus 2ab and then plus b squared. That is the perfect square. Then you also need to know how to factorize perfect squares. That will be a squared minus b squared. This is always a minus b into a plus b. Only the signs will be different, but the terms in each bracket will be the same. So that's how we factorize perfect squares. Then we also talk about, in grade 10, if you remember, we spoke about the sum, or first it was the difference between cubes, where we had a cubed minus b cubed. We also talk of the sum, that is a cubed plus b cubed. When we were taught on how to factorize these, this is what we were taught. We take the first term and the sign that we are seeing, and we write them in the binomial bracket, which means there are only two terms here. So the powers are like not written down. So we are only writing what we are seeing here is a minus b in the first bracket. And we shall have a trinomial in the second bracket. And it's given by squaring the a, and you get your a squared. Then you multiply this times this. that will give you the sign of the middle term will be different from this sign. So it will be plus AB. Then you take this and square again. It will be plus B squared. This is how we factorize a difference between two cubes. Then for this one, it will be A plus B, because I said it's like we forget about the powers. And then the trinomial, we square this, we get A squared. Then we multiply this by this, but we said the sign must be different from this one. So minus AB, then plus B squared. This is how we do our factorization. Now, sometimes the questions will come with, say, A plus B, or this cubed. Now, with this one, those of us who are very weak or in quickly seeing what I'm going to explain here, follow the normal procedure that we have been taught. It will be A plus B into A plus B squared. We know how to do the perfect square. That's what I explained above. How to expand a perfect square, and then we multiply by that. Now, what I want to say here is, right, so you proceed here to expand. This is A plus B into, we know how to expand this, we get that, that's A squared plus 2AB plus B squared. So we have factorized the cubic, the perfect cube. So the same applies with your A minus B cubed. You do the same. I'm not gonna go through that. If you have a problem, please come to me on your inbox so that we can help each other. But as I said, we are looking at differentiation of functions from first principles. Now, when we say we are differentiating from first principles, we are also saying we are differentiating from the definition. So those two words, first principles and the definition, are saying the same thing. So I'll look at example 1. Example 1 is saying consider the function f of x is equal to 2x squared minus 3x minus 5. And part A says determine f dash of x from first principles, or from the definition. So we copy the formula from our exam paper on the page where all formulae is given to us. After doing that, you then write down your f of x, which is defined by 2x squared minus 3x minus 5. Then you write your f of x plus h, which is given by 2. Wherever there is x, we are now putting x plus h, as you can see in this working. There was x, so it's now x plus h squared. There was minus 3x, now it's x plus h, then minus 5. We do our algebra, as we all know. We are expanding a perfect square. We have taught that above, and we end up with that. Then everything else reduces to that long expression. Now check, our formula is saying f dash of x is equal to limit as h goes to 0 of f of x plus h. Do we have f of x plus h in our deliberations? Yes, which is that expression. So that's what we substitute for f of x plus h. Minus f of x. F of x is given to me. So I make use of the bracket because there is a minus, so that the signs inside will change. Doing your algebra, you are simplifying everything. It's all over h. And then at this point, you need to factorize. I think that is very important. You don't just divide h at this point. You factorize so that in bracket you remain with that. Then your h is approaching 0. Wherever there is h, it becomes 0. So we end up with 4x minus 3. Please take note of that. We are moving on to part B. And part B is saying, determine f dash of x. We are now determining f dash of x. Now, it's not f dash of x, it's f dash of 3. So f dash of 3 means wherever there is x in our f dash of x in terms of x, we substitute our 3. So it will be 4 times 3 minus 3, which is 12 minus 3, which gives us a 9. We have found our f dash of 3. Then what is represented by f dash of 3? It's a question. Now our f dash of 3 in part C is equal to 9, which we calculated above, is the gradient of the tangent to f at x equal to 3. Very important for us to understand, boys and girls. Now part D says determine the equation of the tangent to f at x equal to 3. Remember, this is the general formula that we use, and we choose a point that we are going to have. We have a point that we have, which is f of 3, because we are talking of 3 here, x equal to 3. We substitute our 3 into the function, and we end up with a 4. This is the y value. The x value is 3. So we substitute y minus 4, because the y value is 4, equal to m, the gradient, which we calculated is 9, then x minus 3, because the x value is 3, which you can simplify and end up with your equation of the tangent. Part E, we are required to determine the average gradient between x is minus 2 and x is 3. So what we need now is f of minus 2, because we don't have that one. F of minus 2 is equal to 9, and f of 3, we calculated it above, it's a 4. So we substitute 4 minus 9 all over 5, which gives us a minus 1. This is the f of minus 2, the average gradient between x equal to minus 2 and x equal to 3. Part F says determine the equation to the line passing through x is minus 2 and x is 3. Again, we are going to use our formula, where in this case you choose which point do you want to use. In this case, I chose to use 3 and 4. So it will be y minus 4 is equal to minus 1, which is the gradient, bracket, x minus 3, which when simplifies gives us y is equal to minus x plus a 7. Question 2. Question 2 says, consider the function g of x is equal to minus x cubed. Part A, find the derivative of g of x at the point where x is minus 2 using the definition of the derivative. Now we are using the definition of the derivative. So we come, our A is g of x is equal to minus 3. This is the g of x. And now we need g of x plus h. Please take note of that, which means wherever there is x here, we are substituting our x plus h, which when expanded, it gives us this long chain. I think the algebra you are able to do without any hassles at all. Then our g dash of x will be equal to limit of g of x plus h minus g of x, which gives us all over h as h goes to 0. And then we can simplify that. We expand, we substitute now where there is g of x plus h. We place in all that statement or expression, minus in bracket, minus x cubed. When you simplify that, you remain with minus 3hx squared minus 3h squared x minus h cubed, which then reduces to that. And as usual, I said we factorize the numerator for h. H is out, we remain with that. The h will cancel, and we say our h is approaching 0. There is h here, there is h here, so we remain with minus 3x squared. We are moving on to part B. And part B is saying, or we can also be interested to find g dash of minus 2. When we substitute the minus 2 into the derivative, we end up with our g dash of 2 is equal to minus 12. Then part B says, what is represented by g dash of minus 2? G dash of minus 2 is, by definition, represent the gradient of the tangent to g at x equal to minus 2. Part C, determine the equation of the tangent to g at x equal to minus 2. This is more of repetition of what we have done in the previous examples. We take the we write the formula, we substitute our y and our x, and we simplify. We end up with y is equal to minus 12x minus 16. Part D is saying, determine the average gradient between x is minus 2 and x is 2. So again, we need g of minus 2, which is 8, and g of 2, which is minus 8. So it will be minus 8 minus 8, all over 2 minus minus 2, which gives us minus 16 over 4, which reduces to 4. And then part E, which is the last one, determine the equation of the line passing through x minus 2 and x2. Again, all information has been given there. We substitute what we know in this formula for the equation of a tangent, which is a straight line, y minus 8 equal to minus 4, which we calculated above, into x minus minus 2. When simplified, we end up with y is equal to minus 4x.